In this video, we're going to look at another example of partial fraction decomposition with an irreducible quadratic factor in the denominator. You can tell that the degree of the numerator is 2 because 3x squared, that's the leading term in the numerator, has degree 2. And if you were to multiply the quadratic factor x squared plus 4x plus 5 times the linear factor 2x plus 1, the highest degree would be 3 because you get 2x cubed as your leading term. And since 2 is less than 3, we can apply partial fraction decomposition. So let's do that. We have 3x squared plus 7x plus 6 divided by 2x plus 1 times x squared plus 4x plus 5. And we apply the partial fraction decomposition. We get a over 2x plus 1. And for the quadratic term, we get bx plus c divided by x squared plus 4x plus 5. Alright, now let's multiply both sides by 2x plus 1 times x squared plus 4x plus 5 to clear out the fractions. So on the left-hand side, we get 3x squared plus 7x plus 6. On the right-hand side, we get a times x squared plus 4x plus 5 plus bx plus c times 2x plus 1. So let's multiply out the right-hand side. We get ax squared plus 4ax plus 5a plus, fold this all out, we get bx times 2x, that's going to be 2bx squared plus bx times 1, that's bx. Multiplying the inner terms, c times 2x, we get 2cx. And the outer terms, we get c times 1, we get c. Alright, so we have 3x squared. Let's write the stuff on the left-hand side. 3x squared plus 7x plus 6. And 3x squared plus 7x plus 6. Now let's add up all the terms, rearrange them, all the terms that involve x squared. So we have ax squared plus 2bx squared. And let's factor out the x squared. So we get a plus 2b times x squared. Now let's factor out x for all the terms that involve x. 4ax plus bx. So we get 4a plus b times x. Now let's look at all the constant terms. So we have 5a plus c plus 5a plus c. So the next step will be equating coefficients. So on the left-hand side, we have 3, the coefficient of x squared. On the right-hand side, we have a plus 2b. On the left-hand side, the coefficient of x is 7. On the right-hand side, the coefficient of x is 4a plus b. On the left-hand side, the constant coefficient is 6. On the right-hand side, the constant coefficient is 5a plus c. And our job is to solve for a, b, and c. Alright, so what we have is 3x squared plus 7x plus 6 is equal to a plus 2b times x squared plus 4a plus b plus 2c times x plus 5a plus c. We're going to equate equal powers of x, solve for a, b, and c. On the left-hand side, coefficient of x squared, we have 3 is equal to coefficient of x squared on the right-hand side, a plus 2b. Coefficient of x on the left-hand side is 7. Coefficient of x on the right-hand side is 4a plus b plus 2c. Constant coefficient on the left-hand side is 6. On the right-hand side is 5a plus c. Now we have to solve a system of equations, 3 unknowns. Our strategy will be to plug a equals 3 minus 2b from the first equation into the last 2 equations. By doing that, we eliminate the variable a, and we get 2 equations involving b and c. Solving those 2 equations, 2 unknowns, we can obtain b is equal to 1, and we can obtain c is equal to 1, and we plug it into the third equation, c is equal to 6 minus 5a, and that way we can solve for c. So all the constants have been solved for. We have a is equal to 1, b is equal to 1, c is equal to 1. So let's now do the partial fraction decomposition. That's going to give us 1 over, a is 1 over 2x plus 1, plus b is equal to 1, so that's x, and c is 1, x plus 1 divided by x squared plus 4x plus 5. So the partial fraction decomposition has been completed. We now have to integrate. So we have integral 3x squared plus 7x plus 6 divided by 2x plus 1 times x squared plus 4x plus 5, integrate with respect to x, and we apply the partial fraction decomposition to get integral of 1 over 2x plus x plus 1 divided by x squared plus 4x plus 5. Let's split up the integrals and integrate term by term. So on the right hand side, we have integral 1 over 2x plus 1 dx plus integral x plus 1 divided by x squared plus 4x plus 5 dx. The first integral is very easy to do. Integral 1 over 2x plus 1, that's just going to be log of absolute value of 2x plus 1 divided by 2. And this is just applying U substitution, let U equals 2x plus 1, the U is 2 dx. For the integral on the right, we have integral x plus 1 divided by x squared plus 4x plus 5. We're going to have to complete the square in the bottom. If we do that, we're going to get x plus 2 squared plus 1. We're going to talk more about how we complete the square on the last page. All right, so now let's rewrite the left-hand side. We have log of 2x plus 1 divided by 2. Now here's a tricky step. I'm going to rewrite x plus 1 as x plus 2 minus 1. Why do we do that? The reason is, by doing that, we can make the U substitution produce the result for an integral. So now, let's rewrite that. We get log of 2x plus 1 divided by 2. Splitting up the second integral, we get integral x plus 2 divided by x plus 2 all squared plus 1 dx minus integral 1 over x plus 2 all squared plus 1. Integrate with respect to x. So you can see why we did that. Now we can let u be equal to x plus 2 and du is equal to dx. For the last integral, we can do the same choice of substitution. Let u equals x plus 2 and du is equal to dx. Alright, so what we have is integral. The integral has been solved. We have log of 2x plus 1 divided by 2 plus integral x plus 2 divided by x plus 2 squared plus 1 minus integral 1 over x plus 2 squared plus 1. So the result is we have log of 2x plus 1 divided by 2 plus integral u over u squared plus 1, applying the u substitution, dx is just du, minus integral 1 over u squared plus 1 du. So we have log of 2x plus 1 divided by 2. The second integral can be done by doing another u substitution. So you would let w be equal to u squared plus 1 and dw would be 2 du. So the result will be ln of u squared plus 1 divided by 2. And the last integral is just integral of 1 over 1 plus u squared. We know that that's just arctangent. That's minus tan minus 1 of u plus c. Now we'll put u back in. We'll have our answer. So we have log of 2x plus 1 in absolute value divided by 2. Substituting u back in, we get log of x plus 1 all squared plus 1 divided by 2 minus tan minus 1 of x plus 2. Let me make a correction here. This should be x plus 2. X plus 2 all squared. All right, plus c. And let's not forget the constant of integration. So that's the result for the integration. Now let's do a bit of review on the completing the square and the u substitution. So we have y is equal to x squared plus 4x plus 5. The trick is to take this number 4 divided by 2 and square it, and then add and subtract that number. This produces y is equal to x plus 2 squared plus 1. That's the process that we did, completing the square. Now let's talk about some of the integrations that we did. We have, for example, integral 1 over ax plus b dx. This is an easy integration, so we just do that mentally. We say that's log of absolute value of ax plus b divided by a plus c. But let's show some of the work. We let u be equal to ax plus b. du, take the derivative of both sides, we get du is equal to a dx. Solve for dx. dx is du divided by a. The reason there's a in the denominator here is exactly the reason that there's an a in the denominator here. We did another integral x divided by x squared plus 1 dx. So we'll let u be equal to the denominator, x squared plus 1 du. Take the derivative of both sides, du is 2x dx. And divide by 2 both sides, we get du over 2 is equal to x dx. And the result here, of course, is log of x squared plus 1 divided by 2. This is the antiderivative plus c. The reason that there's a 2 in the denominator here is exactly the reason that we have a 2 in the denominator here. All right, thank you. I need to make a correction on last page on the completing the square part. So we have y is equal to x squared plus 4x plus 5. The key concept is to take this number 4 divided by 2 and square it. We get 4. Now we add and subtract this number, plus 4 minus 4. Now we've created a perfect square. This part here is x plus 2 all squared, and 5 minus 4 is 1. That's how we completed the square. All right, thanks.